All right, Speezers, this time we're focusing on what happens when our rectangle is negative, because something special here happens. And when we get there, I'll let you know. We don't see it algebraically because we actually combine the two steps I'm going to talk about in algebra tiles to do it. So make sure you're focused in, locked in, if you will, and we'll be able to get this working for you. So hopefully you have a better understanding. So remember the keys at the top, and then we have how all of this works. So again, what Mr. Spees recommends doing in algebra tiles is they start out with the squares or rectangles, and I'm going to mark them for what they are as I count. So this tells me there's 5 positives. At this point, this 2 is reminding me that I am identifying my terms right now, because that's step 2. Then I have a long negative, because remember I went ahead and made negatives red, and so I have 2 negative x's, because long negatives are variables and our default variable is always x. And then I go over to the right hand side and I put a negative, 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 negative. That's 6 negatives. At this point I've identified all of my terms, so I can translate into algebraic form, and I get my negative 2x plus 5 equals negative 6. So here's the first standard that we can go over. While we almost always write our variables first, and Mr. Spees will, because honestly it doesn't affect me that much. Technically, if the variable term is negative and the constant term is positive, good standards say write the number term first followed by the variable term. I'm not going to hold you to that right now. I'm going to let you know it, and I'm going to write it as I always have until we understand it. Then we can move on about the changes that can occur. Once we know the standard is, we typically start with the variable term. So in this case, again, we're starting with negative 2x, and that came from over here. Then our number term, or our constant term, is our positive 5. And we had 6 negatives, so I write it's negative 6 here, and that equal sign was in between. So really all we're doing is we're taking what we recognize on each one and writing them in order. Now, from here, what I'm going to do is I need to recognize I need 0 pairs to be able to remove these positives. 1, 2, 3, 4, 5. So I have 5 negatives that now match my 5 positives. And that's what this step is when we normally do it. Then we go on, and because I placed 5 negatives on the left-hand side, I have to do the same thing on the right. 1, 2, 3, 4, 5. Now again, remember, I have 2 rectangles, and so I want 2 rows to be able to add up. But when I placed the 5 negatives over here, that matched up with my 6 negatives. When I have 5 negatives and 5 positives, that cancels, just leave me with the negative 2x. And then 6 negatives and 5 negatives equals 11 negatives. Next thing I'm going to do is recognize that I want to evenly distribute all of these negatives into one group. But I'm going to run into kind of a problem here. Excuse me. The first problem I'm running into is I cannot have negative rectangles. That cannot be part of my answer. My answer must be a positive rectangle equals something. So I'm going to change these to positives. When I change them on the left, I'm changing everything on the right. So if these were positives on the right, I'd be changing them to negatives. Since they're negatives, I'm changing them to positives. So I'm now going to have all of these positives instead of all of those negatives. After I've done that, now I can go ahead and distribute these evenly amongst 2 groups. And what I find is I have 11 positives to distribute amongst 2 groups. Now, this is where algebra tiles fails a little bit, because I can't break one of these up to give to 2 different groups. And I have an odd amount in 2 groups. So if you go back and you remember how you were probably first shown division, what that means is you give half of this positive to each group. So we're forming a decimal. Now I don't really want to do that. What I'm going to be doing is taking these 2 groups and splitting them in 2. So I'm going to do divide by negative 2 in parentheses. I do the same thing here. Now notice also algebraically how we turned these positive was the fact that negative divided by a negative is a positive. So that's how it worked out on this side. And on the left-hand side, we had a negative divided by a negative, and that made it positive. All right, with all of that said, what I have is I have my variable where it has 11 positives divided into two groups, and we just keep it like that. We don't need to take the next step and turn it into a decimal. We can just write that because there's this hanging positive, you don't have an even amount to distribute amongst the two groups. I just keep it as the total amount of positives over the total amount of groups we're dividing it into.